Here we go with problem 8. It says determine if the center point is a maximum, a minimum, or a point of inflection. Now, a minimum is when you have basically a parabola or something coming down in this lowest point. That's going to be your minimum right there. Or if it's a downwards facing, the top point would be your maximum. A point of inflection is where the thing sort of turns from going inwards to going outwards. Okay, that's sort of what our point of inflection is. So we got to decide what this is. Well, when we plug x into the function, you and I are getting 9. When we plug 6 in, we're getting this. When we plug 6.1, we're getting this. So let's just think what this looks like. So we have a graph, and when I plug in 5.9, when the x value is 5.9, we're sitting at a height of 9. So that's a dot right there. 5.9, you're at height of 9. When you plug in 6, just a little bit over to the right, you're at a higher point. You're at 9.3. And then when you're at 6.1, you're at 8.9. We're down low, down here at 8.9. Now this is our center point. You can see that what happens is the graph must be hitting that point and then going back down. So this point is at the highest point. Therefore, that is a relative maximum because it's at the highest point. If you and I had a middle point here and other points here, you could see that it would be a what? Well, that point right there would be a minimum. And if we had a point here, the middle here, and then the other guy here, it's sort of swinging like that. And then what happens is that's in the middle, so that's a point of inflection where it starts, it's curving sort of like this, but then it starts curving like that. That's what a point of inflection is. To do these problems, you students get confused with it, but all you really need to do is take a quick look at a graph. When x is 5.9, you're at 9. When it's 6, you're at 9.3. And when it's 6.1, you're at 8.9. Just simply make a quick little graph of it, and you'll see whether you're at the highest point, the lowest point, or in the middle. That's how you do problem number 8.